Hi guys, today we're going to look at adding and subtracting rational expressions. So think back to when you learned how to add and subtract fractions. Unlike multiplying and dividing, we have to have common denominators when we add or subtract two fractions or two rational expressions. So what we want to do is we want to start by seeing what our denominators already have in common so we can figure out what they still need so that they're the same denominator. The best way to see what the denominators already have in common is to factor them. So looking at the first denominator, x squared plus 6x plus 9, they don't currently have anything in common, so I'm going to use a generic rectangle to factor it completely. Starting with my generic rectangle, I'm going to put the x squared and the units diagonally from each other. So we'll put x squareds here and 9 units here. So what that tells me is that the product of each of the diagonals of the generic rectangle have to be the same. So the two that are empty have to multiply to 9x squared, but looking at our problem, we know we only have 6 x's that we need to work with. So that's where our diamond problem comes in. So in the top, I'll put 9x squared, and in the bottom, I will put 6x. Two things that multiply to 9x squared but add to 6x are going to be 3x and 3x. Filling those into my generic rectangle, I go ahead and look to see what outsides could multiply to the inside or what each of the rows and columns have in common. So looking at x squared and 3x, I know they have an x in common, and I also know that x times x will give me x squared. 3x and 9 have a 3 in common. 3x and 9 have a 3 in common. 3 times 3 is 9. X times 3 is 3x, so everything works out. I will rewrite the first fraction as x over the quantity, x plus 3 times x plus 3. And now we'll go ahead and look to the second fraction. X minus 8 doesn't have any factors in common, so I will just continue it as x minus 8. And the denominator of that, they have a 2 in common as a greatest common factor, so I will factor out a 2, and I'll get 2 times the quantity, x plus 3. So because I know that I need to have a common denominator, I'm going to think ahead as to what that common denominator would be. So I'm going to skip down the page just a little bit and think to myself, what do they first have in common? Well, I notice that they already both have an x plus 3 in common. So that means that my common denominator will have to have that x plus 3. Looking at the first rational expression, it has another x plus 3, which means my common denominator will also need to have that x plus 3. And then looking at the second rational expression, I see that it has a 2, so that means that my common denominator will also need to have a 2. The next step in this process needs to be getting my denominators to be the same, or getting them to be that common denominator. So if I look at the first rational expression, it has x plus 3 times x plus 3. So what it's missing from my common denominator is the 2. So I need to multiply by what it's missing. The problem is I can't change the value. So if I multiply the denominator by 2, I need to also multiply the numerator by 2, really multiplying by a giant 1 and then not changing its value at all. So if I rewrite my first expression, x over x plus 3 times x plus 3, I need to multiply it by the 2 to get it to the common denominator, or a 2 over 2 so that I don't change its value. So what I'm going to do is I'm going to multiply this by a giant 1 of 2 over 2 to get it to have a common denominator. When looking at the second expression, it has a 2 and an x plus 3. So from my common denominator, it's missing an x plus 3. So I need to multiply by what it's missing, but not change its value. So multiply by a giant 1 of x plus 3 over x plus 3. So taking my original expression of x minus 8 over 2 times x plus 3, I'm going to multiply by a giant 1 of x plus 3 over x plus 3. Because these both have a common denominator, I can go ahead and add their numerators together. So the numerator of the first one is going to be 2 times x, plus the numerator of the second one is going to be x minus 8 times x plus 3, with the common denominator of x plus 3 times x plus 3 times 2. At this point, I like that my denominator is written as a product. The unfortunate part is that my numerator is written as a combination of a product and a sum, and I don't really understand what that means. And so what I'm going to do with the numerator is I'm going to go ahead and simplify using my order of operations. So looking first at parentheses, I can't do anything inside of the parentheses. So I'm going to move on to exponents, which I don't have any of, and move on to multiplication and division. So 2 times x is 2x. And then I need to take the quantity of x minus 8 and multiply it by the quantity of x plus 3. I can use a generic rectangle to do that, where my dimensions will be x minus 8 by x plus 3. The product will be the inside of this, or the product is the outside, and I can get the sum by finding that product. So x times x is x squared, negative 8 times x is negative 8x, x times 3 is 3x, and negative 8 times 3 is negative 24. That means that my numerator now becomes 2 times x, which is 2x, plus x squared minus 8x plus 3x minus 24. And then I'm going to leave my denominator in factored form as x plus 3 times x plus 3 times 2. I'm going to continue simplifying this now. So looking at my numerator, I have just 1x squared. I can simplify the 2x, the negative 8x, and the 3x. So 2 take away 8 is negative 6, and negative 6 plus 3 is negative 3. So this becomes x squared minus 3x, and then minus 24, all over the quantity x plus 3 times x plus 3 times the 2. At this point, I would like to see if I can factor my numerator. So to begin seeing if I can factor the numerator, I'm just going to set up a generic rectangle to help myself think about this. I know that I'll put my x squared terms and my units diagonally from each other, which means I need my 2 empty portions of my generic rectangle to multiply to a negative 24x squared, but add to a negative 3x. So thinking about the factors of 24, none of them are going to do what I want, which means the numerator is not factorable. And so I can leave my expression as to what it is, or I can distribute the denominator and rewrite it in simplified form. So I would accept this answer, or you can rewrite it as x squared minus 3x minus 24 all over 2x squared plus 12x plus 18. To finish up this problem, I need to talk about the values that have to be excluded in this case, which means I don't want my denominator to ever be equal to 0. So looking up here at my factored form of x plus 3 times x plus 3 times 2, 2 can never be equal to 0, so I don't have to worry about that. X plus 3 and x plus 3 are the same factors, and the only value that will make either of those factors equal to 0 is going to be negative 3. So that means that the only value excluded in this problem is going to be that x cannot equal negative 3. The last thing I want to cover in this video is if you were to subtract these rational expressions instead of adding them. So remember, when you're adding and subtracting fractions, the only difference once you have a common denominator is that instead of adding the numerators, you would be subtracting the numerators. So really, these first few steps are all going to be the same up until I get to that pink step that you see there. So after it's all been factored, instead of adding the two numerators, you would subtract them. So I'm going to rewrite the pink step here. So instead of it being 2 times x plus the quantity x minus 8 times x plus 3, you're going to rewrite it as 2 times x minus the quantity x minus 8 times x plus 3 with a common denominator, which is why we could put them together, of x plus 3 times x plus 3 times 2. I would still use a generic rectangle to help me multiply x minus 8 and x plus 3, but then I'm going to have to distribute that negative to each of the terms inside of my generic rectangle. So when I were to rewrite this one, I would still have 2 times x, which is 2x, but instead of adding that x squared, I would subtract that x squared. Instead of adding that negative 8x, I would subtract the negative 8x or add 8x. Instead of adding 3x, I would subtract 3x. And instead of adding negative 4, I would subtract a negative 24, which becomes plus 24, still all over x plus 3 times x plus 3 times 2. From here, I would go ahead and simplify. So I only have the 1x squared term, so I have a negative x squared. I'm going to take 2x plus 8x minus 3x. So 2x plus 8x is 10x. Take away 3x. It's going to be a positive 7x. And then I have a positive 24. All over the quantity x plus 3 times x plus 3 times 2. At this point, I would still go ahead and see if I could factor my numerator. And just thinking about that generic rectangle, it would have a negative x squared and a positive 24. So I would still be multiplying to a negative 24x squared, but in this case I would be adding to a 7x, and there are still no factors of 24 or negative 24 in this case that would do that, which means I cannot simplify this any further. And so what I can do instead is I can leave it as I have it here, or once again I can rewrite the denominator as 2x squared plus 12x plus 18, and the numerator stays negative x squared plus 7x plus 24. And thinking about the values that would be excluded, it still remains the same, that x cannot be equal to negative 3.